that those of you that are in pre-calculus are going to find easy, so we're probably going to fly through it. So if it's too quick for some of you, let me know. This again we did last year, so we have an idea as to how this works. So today we're looking at radian measure. All right. This guy right here is considered a terminal arm. So this starts it. When I take that terminal arm and I go all the way around the circle, how many degrees does it go? 360 degrees, that's right. Okay, so we have established that it goes 360 degrees around the circle. Now there's another way in which we can measure an angle. So very similar to measuring distances in miles as opposed to kilometers, right? We can do degrees or we can do radian measure. So a radian measure works like this. If I let this be equal to 1 as a distance from here to here, and I wanted to know the distance around the circle, how do I find the circumference of a circle? 2 pi r. Okay, so 2 pi r, that's the distance around the circle. So if my radius is 1, how far around the circle do I go? 2 pi times 1, which is 2 pi. This is what we call radian measure. So we want to be able to tell what this arc length is. Okay? And that arc length is a distance from here to here. It is a portion of 2 pi. We want to find out what it is as a fraction of 2 pi. So for instance, if I let that angle equal 30 degrees, and I wanted to find out what this angle is in radian measure, which is this distance right here, okay? I take 30 degrees, and I have to convert it. That's you. So normally what I could do is if I can go 2 pi over 360 degrees and I can convert it. However, what is the distance from here to here in degrees? Pardon me? 180 degrees. So that's half of 2 pi. So instead of using 2 pi over 360, it's just pi. I'm going to convert using pi over 180 degrees. And I'm going to leave it as pi over 6 radians. Okay? So pi over 6 radians is another way in which we can describe an angle. All right? So to convert, 120 degrees. Let's just take a look and see what it looks like. Again, I start always with the x-axis, and I go from here to there. That is 120 degrees. So let's find out how many radians it is. Again, because you have a calculator, you could take 120 divided by 180, even though you should be able to do this in your head. That's 12 over 18. 6 goes into both. 2 pi over 3 radians. Now, if you're unsure, what you do is you go to your calculator, you hit in 120 over 180, hit enter, go to math, fraction, which is the first thing on it, just hit enter twice, and it'll change it and convert it to 2 over 3. Okay? It says estimate the value of 220 degrees in radian measure. So 220 degrees times pi over 180. Right? Now, they are using actual decimal places, but for right now, let's leave it as exact values by using that. So that's 22 over 18. which is 11 pi over 9 radians. Now you can, in this class, change that to an actual decimal value, but because we're used to doing this in the other class, 11 pi over 9 is actually the most precise value you're going to get. Okay? Radian measures can be in terms of pi, or they can be in terms of an actual value. For example, 11 radians. And we want to find out how many degrees 11 radians is. Well, let's estimate it first, because that's what it actually asks you to do. Let's find out where 11 radians is. How many radians is it to here? From there around to here. How many radians? Pi? So approximately 3.14, right? And then over to here is 2 pi, so 6.28, right? Keep going all the way back to here. What is it? 9.42, right? Down to here,
2 pi over
9.42 plus,
another pi.
not quite another pi,
Oh,
half a pi. So what's half of 3.14? 1.57, correct? Add that on to there, and that takes us to 10.99. So where's 11? Right there. 11 radians. So let's find out how many degrees it is. Times it by 180 degrees and divide by pi. And that one you use your calculator for. Okay? And I'll tell you how many degrees it was. Alright? That's radian measure. Okay. So the next thing we have to do is talk about sinusoidal functions. Okay. So those of you, again, in pre-calculus have a massive advantage here because you understand what the sine graphs and the cos graphs look like right now. So it's going to be up to the applied class. You don't have to go in depth as much as they do. You basically just need to use your calculator and then talk about the pieces of it. So here's how this works. Okay? Let's do this. I'm still going to use, hold on. I'm still going to use a bit of pre-calculus to solve this. So here's how this works. Okay? So again, I'm going to explain something to you that is a little beyond what we want, but it's going to give you a better understanding as to how this works. Okay. So this coordinate right here, we're going to always say that we're going to use what we call the unit circle. So we're going to say that this radius is 1. So that coordinate right there is 1 and 0. Which makes this coordinate right here what? 0 and 1. And over here, -1 and 0, correct? And down here, 0 and -1. Okay. So I'm going to blast through this quickly, but I'm going to give you an idea as to how this looks. If I take any value here, I'm going to make that x and y. Okay, so those of you that haven't seen this, okay, I want you to watch this closely. I drop this down, that means that is y, and that is x, and that is 1. Okay, so far? So all I've done is just take a coordinate. So I drew a line through here. Drew a line anywhere, and I made this coordinate x, y. So it represents any x, y value around that circle. Okay, so far? So that's all it means. If I were to look at it and say to you, what is the sine of the angle? What's the sine of the angle in that triangle? Those of you in pre-calc, just stay quiet. What is the sine of this angle? Well, what's sine? So what's the side opposite the angle? Y, and what's the hypotenuse? 1. So you'd agree with me then that the sine of the angle is y over 1? Right? Sheila? Good. Very good. What's the cos of the angle? So what's the adjacent side to that angle? X over 1. Okay. So what it's saying then is this. Is that if I take any coordinate along here for any angle, the cos of the angle ratio will be my x value of the coordinate. The y will be the sine value of my coordinate. Okay? So what that means is this. All right. Let's say that angle is 0 degrees. Okay? Meaning, I'm talking about this line right here. So if that angle is 0 degrees, the angle is 0. What is the cos ratio? It's 1. And what is the sine ratio? 0. Up here, what's the cos ratio for 90 degrees? 0. And the sine ratio? Okay, so that means then that the cos of 90 is equal to 0, and the sine of 90 is equal to 1. Fair enough? Jenny, you following this? Okay. So what I'm going to do is I'm going to graph this ratio. I'm going to graph this graph of y equals sine theta. Okay? At 0 degrees, what is the sine ratio? 0. At 90 degrees, what is the sine ratio? 1. At 180 degrees, what is the sine ratio?
0.
0. At 270,
-1.
-1. And at 360,
Back to 0.
back to 0. And if I went another 90 degrees to 540, what would it be? It'd be 1. Did I say 540? I think I meant 440.
You meant, yeah. I know
Right?
what you meant.
Okay, so it takes you back to right here. And then it keeps going. So it creates what we call a periodic function. The graph actually looks like this. And it keeps going in both directions. That is where we get the sine graph from. Is from this unit circle. We take all of these values from here, 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 and here, and then back to there, and then we create the sine graph. All right, let's look at the cos graph then. So let's do the cos graph now. All right, what is the cos of 0 degrees? 1. Awesome. What is the cos of 90 degrees? 0. The cos of 180? -1. Cos of 270? And cos of 360? Back to 1. So what's the difference between the two?
First starts at 1.
One starts at 1. Cos graph starts at 1 at its maximum value. And the sine graph starts at what we would call our rest position or equilibrium position at 0. And then it goes up and to the right. So there, right, what I've just done is I have graphed, in red I've graphed y equals sine theta, and in blue or purple, whatever it is, y is equal to cos theta. Okay? These are called periodic functions. They're called periodic functions because they repeat themselves after a given amount of period. When do these guys repeat themselves?
After 360 degrees.
After 360 degrees. Okay? So there's some things that we need to take from this graph then that are important to us. The amplitude. The amplitude is the distance from the equilibrium position, the rest position, to the maximum value. In this case, what is the amplitude in this graph?
1.
1. The distance from here to here is 1. All right. The amplitude helps us with our range. What is the range of this graph then? So looking at this graph, when I look at range, I take the lowest bottom value of the graph and it goes to the highest top value of the graph. So what's the lowest bottom value of this graph? -1. So my range includes -1 and goes how high? To +1. -1 to 1. There's my range. Okay? So the first thing we talk about is amplitude. The second thing we want to talk about is the period of it. When does it repeat itself? After 360 degrees, it starts doing the exact same thing again. So the period for this graph is 360 degrees. The period for any sinusoidal graph, so when I say sinusoidal, I mean either sine or cos, either one. When I talk about sinusoidal, the period for any one of them is 360 degrees over the b value. And I'll talk about b value in a second. Okay? What is the domain for this graph?
Be 0 to 360.
Not 0 to 360. Because it is on the one I drew here, but what do those arrows mean?
Well, keep going. It's, yeah.
Keeps going. So therefore, if it's not 0 to 360, what is it? Right? X is an element of all reals. Negative infinity to positive infinity. Okay? I refer to this, sorry, I'm not really referring to it in the right terminology. I said equilibrium, that's physics. Okay, equilibrium position, rest position. But it's actually called your midline. Okay? That midline will be halfway between your maximum value and your minimum value. That's your midline. So we have period, amplitude, and midline are the three things that you need to know today.
Would you write the range and domain differently? If that's how it's written.
You can write it, if you like the other notation, then you could go -1, oops, not a comma, for sure not a comma. Okay? Here, let me do it right, correct. I'll put it down below here.
Okay.
Okay, the correct way to write the range then,
Is y.
y such that -1 is less than or equal to y is less than or equal to 1, where y is an element of all reals.
Yeah.
That's the correct way to do it. I don't know who did it on that test yesterday. When you write these out, okay, you generally write, except for in this case where you've got from one number to another number, but if you're writing like y is greater than 0, you generally write the variable first. Not 0 is less than or equal to y. It doesn't matter, it's still correct, but I'm just saying, you want to generally write that first. So then the domain then, x such that x is an element of all reals. Like that. Okay?
What did you say the midline was again?
The midline is this line right here
So 0.
that divides it. So in this case, it would be y equals 0, right? But if it moves, if it shifts at all, then your midline may change. Okay? Any questions so far? How are the ones that didn't take this in pre-calc? How are we doing? We're okay so far? Okay, so that's basically all that we need to know from 8.1 to 8.3. All right? The only difference the only thing that adds on to this would be the sinusoidal regression. Okay, and that's the big thing in the applied math course that we don't do in the pre-calc, is we do the regression stuff all the time. So you're basically looking at this and you're punching it into your calculator. And that's the difference. In pre-calc, we have to do all of this without a calculator. In applied, you have the calculator for you. Okay? Any questions about that? All right.
Just leave that first slide up.
Sure. I'm just going to shut the camera.